November 11th, 1942. North Atlantic swells battered the battered hull of the destroyer USS Hambleton as she limped behind the Allied invasion fleet bound for North Africa. Hours earlier, a German torpedo had slammed into her port side, flooding compartments faster than the pumps could breathe. In the darkness below deck, sailors waded waist-deep through freezing water, shouting over the groan of steel twisting under pressure. 8,000 gallons per minute surged inward, more than any standard bilge system could endure. The ship was dying, and the men aboard her knew it. Chief Engineer Lieutenant Porter radioed the bridge, his voice strained with panic. The electrical circuits had shorted, the backup pump had seized, and the main generator was underwater. "She's going down," he warned, yet orders came to hold fast. Every minute afloat meant another crew saved, another convoy warned. Hope, at that point, was measured not in hours, but in gallons. In the chaos, Seaman First Class Arthur Lenz spotted something strange. A small, soot-black gasoline pump running in the corner of the compartment, belching smoke and noise but somehow keeping the water line from rising. It wasn't Navy issue. It wasn't even supposed to be there. Yet its sputtering roar was the only thing standing between life and annihilation. The pump's label, scrawled in grease pencil, read, "Handy Billy." No one aboard the Hambleton knew where it came from or who had built it. They only knew that, miraculously, it worked. As hours passed, that single machine, no bigger than a footlocker, bought time for damage control crews to patch ruptured bulkheads and stabilize the vessel. By dawn, the Hambleton was afloat, battered but breathing, her survival credited to a pump that official Navy engineers had once called reckless. News of the incident reached the Atlantic Fleet within days, sparking confusion, disbelief, and an urgent question at every dockyard workshop. Who had designed this forbidden device, and how had it found its way onto a destroyer under fire? The answer led back to a workshop in Norfolk, Virginia, where one red-haired mechanic had been told again and again that his idea would never work, and had built it anyway. Thomas "Red" Sullivan was not an engineer by degree, but by instinct and defiance. Born in Quincy, Massachusetts in 1907, he had grown up fixing broken fishing boats along the shipyards of Boston Harbor. His hands, permanently scarred from wrenches and wire, had learned that seawater respected only the man who understood how machines breathed under pressure. When he joined the U.S. Navy in 1930 as a machinist's mate, he quickly gained a reputation for arguing with officers and resurrecting dead engines that others had written off. To Sullivan, the word impossible wasn't an order. It was a challenge. By 1942, the war had stretched the Navy's fleet thin, and damage control was a nightmare in motion. Torpedoes could cripple even the most advanced destroyers within minutes. Standard pumps, bulky and power-hungry, often failed when flooding shorted electrical lines. Sullivan, stationed at the Norfolk Navy Yard, watched damaged ships limp in daily, their crews exhausted and their engine rooms half-drowned. He began sketching ideas on scrap paper during night shifts, designs for a portable gasoline-powered pump that could run independent of the ship's systems, light enough for 2 men to carry, yet powerful enough to clear a compartment. His supervisors dismissed the idea outright. Gasoline engines, they warned, were explosive hazards aboard steel warships, capable of igniting vapors and destroying the very vessels they sought to save. But Sullivan refused to abandon his concept. Working after hours, he scavenged parts from discarded lifeboat motors, surplus carburetors, and aircraft fuel lines. He bolted everything to a steel frame, coupling it to an impeller assembly salvaged from a decommissioned cutter. After weeks of trial and failure, the prototype sputtered to life, shaking violently, but drawing a solid stream of seawater from a 50-gallon drum. When his division chief discovered the machine, he threatened disciplinary action for unauthorized modification of Navy property. But Sullivan, stubborn as ever, demonstrated the pump's capability in front of skeptical officers by flooding a barge compartment and clearing it in less than 5 minutes. One commander reportedly muttered, "Reckless, utterly reckless," before ordering tests at the Philadelphia Naval Yard. The trials proved what Sullivan already knew. In war, practicality beats perfection. The Navy refused to approve mass production, yet word spread quietly among repair crews. Copies began appearing on patrol boats and destroyers under whispered code, the Handy Billy. What began as an act of defiance was about to rewrite the meaning of survival at sea. The Handy Billy's first true test came not in a workshop, but amid fire and salt water during Operation Torch in November 1942. Allied convoys plowed through rough Atlantic seas toward the Moroccan coast, carrying thousands of troops and supplies for the first major amphibious assault against Axis forces in North Africa. Among them was the destroyer USS Hambleton, escorting landing craft under a dark sky heavy with threat. German U-boats had been reported prowling the area, their torpedoes hunting the slow-moving invasion fleet like sharks in silence. At approximately 6:50 p.m., a torpedo from U-173 struck Hambleton amidships, tearing open compartments below the waterline. In seconds, steam pipes ruptured, electrical lines sparked, and pumps groaned before falling silent. The forward fire room flooded almost instantly. Panic spread through the engineering crew as seawater surged faster than any system could counter. Damage control reported total power loss, and without suction pressure, the ship's internal bilge pumps were useless. It was then that a junior machinist, remembering Sullivan's reckless contraption stored in a locker, dragged the gasoline pump toward the breach. The crew hesitated. Using an open-flame engine in a flooded steel compartment defied every safety regulation written. Yet desperation often rewrites rules faster than command approval. Two sailors primed the fuel line while another man pulled the starter cord. The Handy Billy coughed, sputtered, and then roared alive, its rhythmic pulse echoing against iron walls. Water began to recede inch by inch, and within minutes, the rising flood stabilized. For the first time since the explosion, the men could breathe without tasting panic. Word spread quickly across the decks. Billy's working. Damage control redirected resources, using the pump to feed secondary hoses into the aft compartments. Against all odds, Hambleton remained afloat through the night. By dawn, tugboats arrived and secured the crippled destroyer for tow to Gibraltar. The official report credited unidentified auxiliary pumping equipment for preventing total loss. When Sullivan read the report weeks later in Norfolk, he knew exactly what those words meant. His secret project, built from scraps and defiance, had kept a destroyer alive under direct attack. Yet instead of commendation, a summons arrived. He was to appear before a Navy Board of Inquiry for unauthorized equipment construction. The machine had proven itself, but its maker was now the target. The Navy Board of Inquiry convened inside a gray-walled operations building at Norfolk Naval Shipyard, its tone colder than the steel it inspected. Thomas Red Sullivan stood at attention before a semicircle of officers whose polished insignia gleamed beneath fluorescent lights. In front of them lay the offending object, his portable gasoline pump, labeled and tagged as unauthorized equipment, subject of investigation. The same machine that had kept the Hambleton from sinking was now considered a violation of naval regulation. To the board, procedure mattered more than improvisation, and defiance of order, however heroic, demanded explanation. An engineering commander opened the proceedings by citing Navy Regulation 148C, which prohibited fabrication of unapproved mechanical devices aboard active vessels. Sullivan listened in silence, his calloused hands locked behind his back, eyes steady but tired. When asked why he had constructed the pump without clearance, he replied simply that sailors were dying faster than paperwork could travel. The answer drew murmurs across the room. He described nights spent watching flooding destroy machinery before standard pumps could even start, and the helplessness of engineers forced to wait for equipment requisitions that never arrived in time. The chief investigator challenged his claim, insisting that the Hambleton's survival owed as much to luck as invention. Sullivan requested permission to present performance logs and field notes recorded by surviving crewmen. Within minutes, affidavits from the destroyer's machinist mates and engineers were read aloud. each confirming that the Handy Billy alone had saved their ship. A copy of the damage control report was produced, detailing suction capacity exceeding all naval standards. The room fell silent. Even skeptics recognized that a device assembled from scrap parts had outperformed every authorized model in active service. Instead of immediate commendation, the board recessed for deliberation. Behind closed doors, officers debated whether rewarding Sullivan might encourage disobedience across the fleet. The decision balanced between discipline and innovation, between tradition and necessity. Hours later, the board reconvened, issuing a formal reprimand but halting all punitive action. Sullivan would keep his rank, though his design remained classified pending review. He walked out of the room, neither a hero nor a criminal, just a mechanic vindicated by results, yet constrained by hierarchy. Unknown to him, within days, whispered copies of his blueprints were already spreading across shipyards from Charleston to Pearl Harbor. Within weeks of the inquiry, copies of Sullivan's design began appearing across naval workshops, disguised as modified bilge units or temporary pump assemblies. In Charleston, a machinist's mate reproduced the Handy Billy using aircraft carburetor tubing. At Pearl Harbor, a maintenance officer quietly requisitioned surplus fuel hoses, citing damage control training needs. By spring 1943, the design had spread through the Pacific like a rumor wrapped in steel. Every man who built one risked disciplinary action, yet every ship that carried one sailed a little safer. What began as one mechanic's defiance was evolving into an underground engineering movement driven by necessity, not permission. Naval Command, aware of the spreading improvisation, launched official investigations into unauthorized mechanical devices. Memos from the Bureau of Ships warned that the untested equipment might explode if improperly handled, especially near fuel lines. Still, the reports from the Atlantic and Mediterranean contradicted every concern. Ships fitted with Handy Billy variants survived flooding incidents that would have once doomed them. Damage control officers began keeping one hidden beneath deck plating, accessible only during emergencies. It was an open secret among sailors that when the approved pumps failed, Sullivan's reckless invention became their last hope of survival. By late 1943, the pump's reputation reached even the British Admiralty. Technical representatives from the Royal Navy, hearing of a Yank contraption that drinks seawater and spits life, requested blueprints through unofficial channels. American bureaucrats denied the transfer, yet copies arrived anyway, smuggled inside toolkits aboard Lend-Lease convoys. Across the Atlantic, Royal Navy repairmen began assembling British modified versions, adding safety valves and reinforced joints. The shared innovation created a rare moment of transatlantic engineering unity, built not from orders, but from faith in what worked. Resistance persisted within Washington. Senior officers accused the sailors of undermining standardization, while field commanders insisted the pumps had saved irreplaceable tonnage. The Bureau of Ships finally commissioned a small-scale test under controlled conditions at the Philadelphia Naval Yard. Engineers watched as the Handy Billy drained a flooded mock compartment in under 2 minutes, half the time of the Navy's best electric model. The results were undeniable. What had been mocked as reckless improvisation was now empirical success. Bureau officials authorized limited production, though the original inventor's name remained absent from the documents. Red Sullivan, meanwhile, continued repairing engines aboard destroyers, unaware that his creation had already saved more ships than any weapon he ever serviced. By early 1944, the Handy Billy had become as essential to Allied fleets as ammunition or food, though it carried no official serial number. Sailors trusted it more than their superiors did, nicknaming it the heart pump, because it kept steel alive under fire. From Sicily to Saipan, its rhythmic thumping became the hidden soundtrack of survival, echoing through shattered bulkheads and smoke-filled compartments. When explosions silenced every other machine, that portable gasoline engine still roared, drawing seawater out of the wounded ships that refused to sink. For the men aboard, it was more than a tool. It was a lifeline forged by one man, refusal to accept failure. On the destroyer USS Bori, a Japanese bomb ripped through the aft engine room, flooding the lower decks faster than any standard pump could handle. Damage control teams, operating waist-deep in oil and darkness, connected a handy billy through ruptured conduits. Within minutes, the flood slowed, buying time for the engineers to seal the bulkhead and stabilize the ship. Reports of similar rescues appeared daily across Pacific command logs, usually written in brief technical language. But between the lines lived something more profound, a quiet gratitude for the unknown mechanic whose reckless contraption refused to quit. In the brutal Philippine campaign, convoys carrying ammunition and landing craft faced constant aerial and submarine attacks. Handy-billy units, mounted on decks and lashed beside lifeboats, became the difference between abandonment and endurance. Sailors risked enemy fire to operate them, often kneeling beside gasoline fumes as they fought back floods with nothing but stubborn courage. Their simplicity made them unstoppable. No electricity, no delicate valves, just mechanical willpower driven by gasoline and human grit. They worked in jungle humidity, Arctic frost, and blazing tropical sun with equal determination, embodying the spirit of the men who carried them. By war's end, more than 40 damaged ships were recorded as saved by portable pumps, though few official histories named Sullivan or credited his creation. Bureaucrats preferred to list the results under damage control efficiency improvement. But among sailors, no one cared about paperwork. They knew what saved them. They'd seen the small red-streaked machine coughing out seawater and life at the same time, its rhythmic beat echoing like defiance against the ocean's hunger. The handy billy had become the unspoken hero of the fleet, a symbol of human ingenuity triumphing over mechanical despair. When the war's thunder finally faded, Thomas "Red" Sullivan returned to Norfolk expecting a handshake, perhaps even a citation for heroism. Instead, he found an envelope stamped official reprimand. The Navy Bureau of Ships accused him of unauthorized modification of government equipment, misuse of resources, and breach of procedural discipline. His pump, the same device that had saved thousands of lives, was technically unapproved, built from scavenged parts, and lacked the required engineering certification. Bureaucrats saw it not as innovation, but insubordination. In an era obsessed with order, creativity was treated like chaos. During his hearing in late 1945, a line of officers testified to the handy billy's effectiveness. Damage control specialists from the Hambleton, Bori, and Corey described in unemotional naval language how the pump's continuous operation prevented catastrophic flooding. Yet regulations carried more weight than testimony. One commander, frustrated by the proceedings, muttered that if Sullivan had failed instead of succeeded, the Navy would have promoted him for trying. The court's decision stopped short of a full court-martial, issuing only a formal reprimand, but the damage to his reputation was done. Innovation, it seemed, had no uniform. Sullivan returned to civilian life, taking work as a dock mechanic, still carrying the scars of both the war and the system he had served. For years, sailors wrote to him quietly. Letters of thanks, stories of ships that refused to die, photos of the battered pumps still running long after peace returned. He never sought recognition or payment. When asked why he had built the pump in secret, he replied that drowning was a poor way to honor regulations. His tone carried no bitterness, only the weary acceptance of a man who understood the price of defiance. Meanwhile, Naval Procurement Archives began listing portable gasoline damage control pump Type B under standard inventory. Thousands were ordered for post-war ships, each built according to Sullivan's original design. No credit line mentioned him. Historians studying wartime engineering decades later would find only a brief annotation. Origin, unknown field modification, 1942. Yet among those who had knelt beside flooding bulkheads, the name, "Red" Sullivan, became quiet legend, a whispered acknowledgement passed through generations of sailors who knew that sometimes the best orders were the ones never given. By the late 1940s, long after the last wartime convoys had faded from the Atlantic, Red Sullivan's pump continued to serve quietly across oceans. The Navy standardized it as the Handy Billy portable pump, type B42, assigning it a production code rather than a name. Yet every sailor who handled one knew its origin. From destroyers refitted during the Korean War to newly launched Liberty replacements, the compact gasoline pump became as essential as the life jacket. In training manuals, it was listed simply as a reliable emergency auxiliary, its extraordinary birth deliberately omitted. Bureaucratic anonymity had buried the man, but not his creation. Civilian shipyards soon copied the design for commercial use, fitting modified units aboard trawlers, cargo ships, and fireboats. Its small size, rapid output, and durable carbureted motor made it indispensable for coastal rescue teams. By the mid-1950s, the U.S. Coast Guard had adopted a variant known as the P3 portable salvage pump, capable of moving 8,000 gallons per minute, the very figure that once marked the Hambleton's death sentence. Maritime historians later noted that Sullivan's prototype marked a turning point in field engineering, where necessity overtook doctrine and innovation flowed from the lower decks rather than from command offices. In engineering circles, the pump's influence reached even further. The principles behind its balanced impeller system and light aluminum casing shaped post-war industrial pumps used in refineries and municipal drainage projects. Decades later, in 1979, NASA ES Environmental Systems Division referenced Sullivan ES concept while designing emergency water evacuation units for the Skylab re-entry capsule program. What began as one mechanic's defiance had become part of global engineering language, a testament to the enduring utility of practical genius born from desperation. Yet among sailors, the pump remained something more than machinery. It became a symbol of the will to fight on when structure and steel gave way. Veterans of the Atlantic and Pacific theaters told their sons about the night the Handy Billy roared to life beneath rising waterlines, its sputtering motor echoing like a heartbeat. In naval museums, preserved units sit under dim lights, plaques reading, Type B42 portable pump, though curators quietly add another note to visitors who ask. The true story, they explain, belongs not to the Bureau, but to a red-haired mechanic who refused to let ships die. By the early 1960s, Thomas "Red" Sullivan had become a ghost within the very Navy he helped save. His name appeared nowhere in procurement records, patent filings, or official commendations. He lived quietly in a weathered bungalow near Portsmouth Harbor, repairing fishing engines, and occasionally visiting the shipyard where he once defied orders to build his reckless pump. Locals knew him as the man who could fix anything mechanical, but few realized that his invention had saved more lives than many decorated admirals. He spoke little about the war, his stories always trailing off when questions turned toward recognition. To him, the ocean had taken enough without demanding memory. In 1965, a young naval historian named Margaret Halverson stumbled upon a curious anomaly while researching wartime damage control equipment. Every post-1942 pump she examined matched an uncredited design prototype from Norfolk. Tracing field reports, she found references to a red-headed mechanic aboard the USS Hambleton, whose pump had performed beyond specification during the North African campaign. Her discovery reignited interest in an invention long considered anonymous. Letters from surviving sailors soon arrived at her office, filled with recollections of Sullivan's determination and the frantic moments when his handmade machine refused to quit. By 1971, Halverson published The Handy Billy Story, a naval engineering monograph that reconstructed the origins of the device. The report, circulated among maritime academies, listed Sullivan as inventor, machinist, and unrecognized innovator. Veterans organizations began petitioning the Department of the Navy to issue a posthumous commendation, though the process met bureaucratic resistance. The Navy's archives, embarrassed by decades of oversight, quietly acknowledged his role but declined formal recognition, citing insufficient documentation. For Sullivan, who passed away in 1974, the matter remained unresolved in life, but far from forgotten in legacy. In the years following his death, his name began appearing on plaques at shipyards, memorial dedications, and engineering symposiums honoring unsung innovators. Sailors of a new generation, raised on stories of impossible courage, came to regard Sullivan's Handy Billy as proof that greatness often begins with stubborn defiance. His life illustrated a timeless truth buried beneath naval history's steel decks, that one person armed with tools, conviction, and reckless belief can hold back the ocean itself. Today, long after the last rivets of World War II ships have rusted beneath silent seas, the echo of Thomas Red Sullivan's defiance still hums through every rescue siren and every portable pump that springs to life against rising water. His Handy Billy, once dismissed as reckless and unauthorized, became the blueprint for countless emergency systems protecting both sailors and civilians worldwide. Every modern vessel, from nuclear submarines to oceanographic research ships, carries within its engineering lineage the same principle that drove Sullivan to break rules: the belief that survival demands creativity unchained from bureaucracy. His defiance was not rebellion for pride, but rebellion for life. In naval academies, his story is now taught quietly, alongside the great innovations of the 20th century, not for its technical perfection, but for its audacity. The lesson remains clear, that leadership is not defined by rank or ribbon, but by courage in the face of apathy. Sullivan's pump was more than a machine. It was a heartbeat fashioned from metal, wrench, and willpower. Historians studying innovation ethics often cite his case as proof that heroism sometimes exists in disobedience, when conscience overrides command and ingenuity becomes the last defense against destruction. For those who stand at sea today, his spirit endures in every engineer who refuses to accept failure as final. In hurricane zones, firefighting teams still rely on descendants of the Handy Billy to drain flooded cities, its rhythmic roar echoing across disaster sites, much like it did through the shattered hull of the Hambleton. Few of the men and women operating those pumps know his name, yet they trust his invention with their lives, a quiet continuity of purpose that transcends generations. His hands, long gone, still guide theirs through the machine-ass vibration and the hum of the motor he once built in secret. The ocean remains indifferent, its depths claiming ships as it always has. But Sullivan's creation stands as defiance against that indifference, a mechanical prayer whispered through time. In every drop expelled from a sinking hull, in every ship that survives because pressure meets resistance, there lingers the unseen legacy of a mechanic who refused to surrender. History remembers his machine. Humanity remembers his courage.